Okay, let's go over lesson 12.4, page 660 in your book, dividing rational expressions. Dividing rational expressions, just like we learned yesterday, it's really just a multiplication problem. All you have to do, remember, is reciprocal and multiply. So, just like in third grade we learned how to multiply fractions, you got a over b times c over d. You change the, divided by c over d. You change the division sign to multiplication, and you reciprocal the second number. So c over d becomes d over c. So reciprocal and multiply. And so a over b divided by c over d equals a times d over b c. Let's see that in real life. Here's an example. So I'm going to first write the problem again. But this time I'm going to change the division to a multiplication, and I'm going to reciprocal the second number. Now I can cross cancel. 7, 7, 1, 7, 7, 3. X squared goes away. That leaves me with just an x. 5 goes away to a 1, and this is a 2. So you can say 1 times 3 on the top, then 1 times 2x on the bottom, and there is my final answer. And all I did was take the division sign, make it a multiplication, reciprocal it, and then I multiplied just like normal. Problem number 2, n plus 1 all over n plus 3 divided by 2n plus 2 all over n plus 4. First thing is rewrite it with the reciprocal and change the multiplication. Next thing I see is that I can rewrite this as 2 times n plus 1. I factored a 2 out of both of them. Now the n plus 1 cancels the n plus 1. And I'm left with n plus 4 all over 2 times n plus 3. And if I want to, I can multiply that out, n plus 4 all over 2n plus 6. Try number 3. Number 3, 5a plus 10 all over a plus 5 divided by a simple a plus 2. Well, in this case, the a plus 2 is really a fraction over 1. So when I reciprocal and multiply, I rewrite the first number as is, change the multiplication, and now the reciprocal of a plus 2, remember, is really over 1, so I say it's 1 over a plus 2. Okay? Then I see right away that I can factor a 2 out of this guy and make this, or excuse me, a 5 out of this guy and make this 2a plus 2. Actually, it makes it 1a plus 2. 1a plus 2. And that a plus 2 and that a plus 2 cancel out. And I'm left with 5 on the top and a plus 5 on the bottom, and that is my final answer. Let's try number 4. M squared plus 3m plus 2 divided by 4. That whole thing divided by m plus 2 all over m plus 1. Alright, so let's rewrite it. M squared plus 3m plus 2 all over 4 times m plus 1, we're reciprocal, m plus 2. Now I'm going to factor this top guy, m and m, and 2 times 1 adds up to 3 times. There's my two numbers, so this has been factored. Now m plus 2 and m plus 2 cancel out. I'm left with m plus 1 times itself, so squared, all over 4. That's the answer. Number 5. This one is a dimensional analysis problem. If I have 309 days, and I have 466 million miles, and I want to find my miles per hour. Alright, so I'm going to start with 466,000,000 miles in 309 days. That's how far I travel. It's a satellite. Okay, then I say to myself, in one day, it's 24 hours. So I'm going to convert my days to hours, so that's what I want, is miles per hour. I've got miles, days cancel, so I'm left with hours. So that's all the further I have to go, because day cancels day. So I'm left with miles per hour. So I know that my answer is 466 million divided by 24, which gives me 62,837.11 miles per hour, and that's approximate. Since I'm rounding, it's an approximate.